Hello everyone, welcome back. Today we are going to discuss about the IUPAC nomenclature of fused hydrocarbons. So what are fused hydrocarbons? A fused or condensed polynuclear hydrocarbon are compounds in which two or more benzene rings are fused to each other and they have at least two carbons in common. For example, naphthalene, when two benzene rings are fused together, when there are three benzene rings which are fused together in a linear fashion, we call it anthracene. When the three benzene rings are fused together in an angular manner, then we call it phenanthrene. Now, how to give the IUPAC nomenclature for these type of compounds? To indicate the position on the fused hydrocarbon, for example, naphthalene, anthracene and phenanthrene, there is a need to number the ring. The numbering of naphthalene, anthracene and phenanthrene ring is done in a manner which is shown below. In case of naphthalene, the numbering starts from this carbon and it goes like this: 1, 2, 3, 4, 5, 6, 7, 8. So, the carbon next to the fused carbon is numbered as 1. So, you can number this as 1, or you can number this as 1, or you can number this position as 1, or this position as 1, and accordingly we have to put the other number. Similarly, in anthracene, the numbering starts from this carbon and it goes like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, the numbering starts from the outermost ring, which can be this or this, and 1 can be this carbon or this carbon or this carbon or this carbon, and the other numbers goes accordingly. In phenanthrene, the numbering starts from the outer ring and it is like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, we can see the inner ring are numbered as 9 and 10. The carbons of the inner ring are numbered as 9 and 10. In naphthalene, this 9 and 10, we can't put any substituent at 9 and 10 position. So, there is no point in numbering them. These rules will become more clear when we will do more examples. Now, you know that there are two types of substituents. One is called principal functional group and its name comes as a suffix along with the parent name. All these things we have done in the earlier videos. So, if we put a principal functional group like SO3H group, what is SO3H group? Sulfonic acid group. Sulfonic acid group is a principal functional group. So, its suffix name will come along with the parent name, and so what is the name of this compound? This is a naphthalene. This is a naphthalene derivative, means the main ring is naphthalene on which you have a sulfonic acid group as a substituent. And sulfonic acid group is a principal functional group. So, its name will come in the suffix. So, what is the name of this compound? The name of the compound is naphthalene 1 sulfonic acid. because the sulfonic acid is situated at one position. What is the name of this compound then? See, the OH group is now not situated at one position. It is situated at two positions. So what is the name of this compound? The naphthalene, and we know that OH groups are alcohol group, and it is indicated as a suffix name all. And where is it situated? It is situated at the two position. And so what is the name of this compound? The name of the compound is naphthalene 2-all. What is the name of this compound? Here also we have a naphthalene ring with a NH2 group, that is an amine group, and amine is a principal functional group. But where is it situated? It is situated at the second position. The second position of the fused carbon. And so, what is the name of this compound? Naphthalene 2-amine. I hope you remember the priority table which we have discussed in video 7 and 8 of the series of videos that we have published. And this is the other priority, that's priority table of the principal functional group. Now coming to the substituents, coming to the functional group which only acts as a substituent and whose name come as a prefix. It's these type of functional groups has name never come as a suffix. It comes as a prefix. We know there are some substituents which come as whose name comes as a prefix. Some of them are halides, nitro, ethers like methoxy, ethoxy. They never come as a suffix name. They always come as a prefix name. So what is the name of this compound? See, we have a naphthalene ring having two nitro groups. So we have to mention the position of the nitro groups, and then only we can name this, give a IUPAC name to this compound. So what is it? Let's start numbering. Since both the nitro groups are situated at the same position, you can start numbering either from here or from here. So let's start numbering from here. So 1, 2, 3, 4, 5, 6, 7, 8. So how are the nitro groups situated? Where are the nitro groups situated? They are situated at 1 and 5 position. And so the nitro groups, the name of this compound is 1,5-dinitronaphthalene. See, the nitro group comes as a suffix name, not as a, the nitro groups comes as a prefix name and not as a suffix name. What is the name of this compound? The name of this compound is, see, this is an anthracene compound. Okay, this is an anthracene derivative. And where are these two bromo groups situated? These two bromo groups are situated on the central benzene ring. And so the numbering goes like this: 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So the bromo groups are situated at 9 and 10 carbon, on the 9 and 10 carbon. And bromo, the name bromo never comes as a suffix. It is always as a prefix. And so the name is 9,10. Here it will be dibromo. And I have written it only bromo, but it will be 9,10 dibromo anthracene. I hope you remember this table where we have discussed about the functional groups which comes only as a prefix name, and in video, that is in video 8 of the series of videos that we have. Now, how to give a IUPAC name of a fused hydrocarbon having two or more different functional groups. If there are in the earlier examples, we have seen that either the fused hydrocarbon is having one functional group or it is having two similar types of functional groups, similar functional group. Now we will be discussing about certain examples where we have a fused hydrocarbon having two different functional groups. Now when we talk about two different functional groups, now one functional group should get preference in numbering and than the other functional group. So what is the rule? When there are two or more different functional groups, first the more functional group should be selected with the help of the priority table, which I have shown you before. Just before this slide, I have shown you some priority table. So from the priority table, we have to see that which functional group gets preference and we have to select that. Now secondly, the numbering of the fused hydrocarbon should be done in such a way that the preferential group gets the minimum number. What is the third rule? The third rule says that the other groups automatically gets the number following the sequence used to number the fused hydrocarbon rings, which we have already learned before. This is the way to number a naphthalene ring, this is the way to number an anthracene ring, this is the way to number a phenanthrene ring. Now let's see some examples. Okay, first we will deal with this example. This is a naphthalene ring having two substituents. What are they? One is bromo and the other one is nitro. Now both bromo and nitro comes as a prefix name. So, but who gets preference? Always halides gets preference over the nitro group. That we come to know from the priority table. And so bromo gets number 1 and nitro gets number 5. Now while writing the prefix name, remember we have to follow the alphabetical order. So what is the name of this compound? The name of this compound is 1 bromo 5 nitro naphthalene and not 1 nitro 5 bromo naphthalene. Similarly, what is the name of this compound? See, this is a naphthalene ring having 3 substituents. What are they? They are all halide substituents. One is bromo, chloro, iodo. Now again from the priority table, you know that who gets preference among these halides? Bromo, chloro or iodo. Bromo gets preference over chloro and chloro gets preference over iodo. If you have forgotten this, go back to the priority table, see the priority order. So the numbering will start from the bromo group. So it goes in this manner: 1, 2, 3, 4, 5, 6, 7, 8. Remember, we can't do numbering like this: 1, 2, 3, 4, 5, 6, 7, 8. We can't do like this. We have to start numbering from the carbon next to the fused carbon, and then we have to go like this: 1, 2, 3, 4, and then to the next ring: 5, 6, 7, 8. So now bromo gets 1 position, chloro gets 3 position and iodo gets 5 position. All these name comes in the prefix. And while writing the name, we have to follow alphabetical order. So obviously the name of this compound is 1-bromo, 3-chloro, 5-iodo, naphthalene. What is the name of this compound? It is again a naphthalene ring having a nitro group and a sulfonic acid group. Now, who gets preference? Principal functional group always gets preference over the substituent. So, who is the principal functional group? SO3H, sulfonic acid. Go back to the priority table and see whether the sulfonic acid is there in that table. Sulfonic acid is a principal functional group, and so it gets preference over the nitro group. And so the numbering obviously will be from where? Will it be from here, this bottom carbon, or it will be from here? Obviously, it will be from here, because once we start numbering from this fused carbon, next to this fused carbon, sulfonic acid group gets 2 number, but if you start numbering from the other fused carbon, from the carbon next to the fused carbon, sulfonic acid group, the number increases, and that is not the rule. The rule is the group should get minimum number, the preferential group should get minimum number. So this is the best possible way of numbering, and so you can see that sulfonic acid group is at 2 position, nitro is at 8 position. Now nitro group comes as a prefix. The name of the nitro, the name 8 nitro will come as a prefix name, and 2 sulfonic acid will come as a suffix name. So what is the name of this compound? Can you guess? It will be definitely 8-nitronaphthalene 2-sulfonic acid. Coming to the next example, look at this compound. This is an anthracene derivative having cyano or a nitrile group and a carboxylic acid group. Now these are both principal functional group. If you see the priority table, who gets preference? Carboxylic acid group gets preference over the nitrile group. So who will get preference in numbering? Carboxylic acid group will obviously get preference in numbering, and so the numbering goes like this. Now, while naming, though cyanide, cyano group is a principal functional group, but in presence of carboxylic acid group, the name cyano will come as a prefix and carboxylic acid group will come as a suffix. So what is the name of this compound? The name of the compound is 4-cyanoanthracene 1-carboxylic acid. We have done all these type of examples earlier also with benzene ring and with other substituents also, okay, with other systems also. So this is nothing new for us. So I hope you all remember the trick which we have learned to remember the principal functional group. Come, sit, eat apple, almond, naka, tea, and announce, all applaud. So what is the priority order or preferential order? Come. Come, C is for carboxylic acid. Then the next preferential group, sit, S is for sulfonic acid. Eat for ester. Apples, A for acid chloride. Almonds, A for amide. Then coming to NaCa, N of NaCa is for nitrile. A of NaCas, A is for aldehyde, K is for ketone, A is for alcohol. Then T is for thiol, and A is for amine, announce, A is for alkene, all, A is for alkyne, and A for applaud, A of applaud is for alkene. So you see, in the previous example I was telling that carboxylic acid will get preference over nitrile. So it is same. See, carboxylic acid is at 1 position, whereas nitrile is at 6 position. So when carboxylic acid and nitrile is there in the same compound, so carboxylic acid gets preference while numbering, followed by nitrile. Now comes for assignments, some assignments for you. There are 15 derivatives, fused hydrocarbon derivatives, and you are to write the IUPAC nomenclature of these compounds. So you close the video, stop the video, try it yourself to write the IUPAC names, and then come back and see the answer. See, the first compound is a naphthalene derivative having NH2 group and SO3H group. So what is the name of this compound? This name of this compound is 6-amino-naphthalene 2-sulfonic acid. Similarly, the next compound is also a naphthalene derivative having a OH group and 2 nitro groups. So OH will get preference over the nitro group, and so the numbering starts from here, and so the name of this compound is 2,3-dinitro naphthalene 1-ol. Like this, you try to solve all this, give the IUPAC all these problems and give the IUPAC name of the compounds. The answer, the solution for these problems are given here. But you try to solve yourself and then check whether those answers are matching with these solutions. That's all for today. If you like my video, please subscribe, like, share and comment. Before I end, I want to end with a thought. Umbrella can't stop the rain, but it makes us stand in the rain. Confidence may not fetch success, but give us power to face any challenge in life. Thank you and bye.